welcome to another set of video notes. Today we're working on 1.6 and we're going to look at solving linear inequalities. So what's really different from everything we've done so far is that word in. Hopefully you remember inequalities from classes past. Less than is this symbol, greater than is this symbol, and you were probably taught that from a pretty young age. We can also talk about less than or equal to. We can talk about greater than or equal to. But the one thing now that you're a big boy and girl that you need to remember is that this way of remembering only works when you're reading from left to right. Okay? We'll get into it a little bit more why that's important, but I just want you to remember. So like down here, we're saying x has some relationship to -5. Do you guys know what this is? Well, look back up there. It's greater than. So there's lots of numbers that are greater than -5. -4, -3, -2. It could be -1.5. It could be 2/3. So we don't want to just write it like this. Sometimes it's nice to represent it with a graph. So back to our number line. And you find -5. Now, where are all the numbers that are greater than -5? Are they to the left, things like -6 and -7, or are they to the right? Most of you are really good at this. You know it's to the right. And the one thing that we're going to do, because you could be here at like -4.9999999, and that is greater than, but I don't want to write that out, so I'm just going to use a round circle. And it means every number except for -5. So this is what I'm going to expect to see when you graph those. Remember, I always want to see the 0. I'll need to see a closed circle, or well, open. We'll look at closed in a minute, and which direction it's going. Okay? Here we've got another one. Hopefully you're reading this with me. Use your cheat sheet if you have to. X is less than or equal to 3. So when you go to graph it, put in your 0, 1, 2, 3. Now, we mark 3, and we want the stuff that's less. So going to the left, isn't that nice? The stuff that's less goes to the left. But we're saying it could be 3. 3 would make this a true statement. We want all the numbers that make this true. Well, there's tons up here. Does 3 work? Is 3 less than or equal to 3? It is. So you're going to close in the circle, and that's the little slip I just said before. Open circle for regular, closed circle for or equal to. Okay? These are actually called compound inequalities because they have 2 parts to it. And this is the one I'm concerned about you looking at, because you're probably really good at saying, yes, x is less than 1. But this also represents and x. Now look, what's this side that's closest to the x? Is it the little or the big? It's the big. So really you'd read this as x is greater than or equal to -3. See how we switched the sides they were on, and we also flipped the sign. Okay? So what we're looking for are all the numbers that are less than 1 and greater than or equal to -3. So we can put this on the same number line. Let's see, less than, open hole. Less than 1, go to the left. Okay? So that's what that part is. We're going to separate it for a minute. Greater than or equal to -3. Well, let's see. -3. Open or closed hole? What do you think? Closed? Good. And where are the ones that are greater than? To the right? Yes, and that's your other little way to remember. Greater goes to the right. Work on your phonics at the same time. Okay, so these keep coming this way, and this keeps going this way. But I use the word and, so it's got to be true for both of these. This is when it's nice to just put it on one number line. So we have an open circle at 1, we have a closed circle at -3, and we want the stuff that's in between. Okay? You almost all the time, if you see a compound inequality written like this, it's going to be that where it starts one place, ends at the other, okay? Here's our last kind of compound inequality. Notice it says an or. Well, let's go ahead and graph this. This says x is, good, less than 1. Open or closed? You're right, open. And we want to the left because it's less than. So this is going to be a little more involved. You're going to have to decide where do I make a mark, open or closed, and which direction. Let's go ahead and do the other one, and I'm going to show you something. This time we go up to 2. Open or close? Closed, good. And do we go to the left or to the right? To the right. Okay? Now, if you tried to put these together, they wouldn't overlap, would they? Unlike here, where they kind of have something in common, and it's got to be a part of both. This says or, so I don't care if it's a part of both. Just one or the other is fine. So most of the time, if you graph a compound inequality that has or there, you are going to see it's shooting out in opposite directions. So when you have it written like this, it's a nice little closed-in thing. When you've got the or, you're going to go in 2 different directions. And that's something you can pretty much always count on, okay? The next thing that we need to talk about is solving inequalities. Now, you've done a lot of work on solving equations. Doing pretty well with that. But the one thing about solving inequalities is that we need to review adding and subtracting. Only thing you really have to remember is what you do to one side, you have to do, must do to the other. Okay? That's probably nothing different than what you've done before. But now what we need to worry about is multiplying and dividing. And hopefully some of you have seen this before. If you have something like negative x less than 5, how would you get the x by itself? Oh, Mrs. Roth, we've seen this before. We know. You would divide each side by negative 1. Okay? I agree with that, but here's the trick with inequalities. You actually have to flip that inequality symbol if you are dividing by negatives, okay? So if you either multiply or divide by a negative, you must flip or turn, maybe you might want to call it turn, the inequality sign. Now you might say, why did you make such a big deal about the inequality sign? Remember over here when we talked about, sorry, am I making a motion sick yet? Oh, that if you rewrote it, the x first, we flipped the whole thing here. I'm not saying that. I'm saying change the symbol from a less than to a greater than. Okay? So we're going to practice this. We have four more problems to go through. Sometimes we'll have x's on both sides. So like here, you might think, well, I don't know. Let's take care of the numbers. Let's take care of the x's first. How do we want to get rid of this? Subtract it, good. So it's a positive, so to get rid of it, we subtract it. Now if you notice, I'm going to still write an equals because I don't know how, they're the same thing. And this way it helps me keep track. So carry the 3. What is negative x minus x? This could be a problem, but it is negative 2x. Did any of you think you should cancel it? Yeah, watch your signs. Negative 1 minus 1 is negative 2. Right, this side, we haven't multiplied or divided by a negative, so I'm good. Stays the same, and I'm left with negative 9. Now, what else do we need to do? Right, get rid of the 3, so we're going to subtract it. Notice I keep that equal sign, so I know it's on each side. What's left on the left side? Negative 2x. What is negative 9 minus 3? Negative 12. Do I need to flip it yet? Or switch the sign? Nope. Haven't done anything that requires me to do that. Okay, now, divide each side by negative 2. What is negative 12 divided by negative 2? It's 6. Hey, do you notice something? Yep, now we need to flip it because we divided by a negative. Okay, so the numbers that work for this equation are, open or close? Open, awesome. Left or right? Left. So any of these numbers should work. And we could even test, put in say 0. Is 3 greater than negative 9? It is, it works. All right, next, we have a compound inequality. Now, when it's written like this, that has the and thing, you can solve it just the way it is. Okay, so look inside, you've got 2x plus 7. What are you going to get rid of first, the 2 or the 7? The 7? Okay, so we're going to subtract 7 from this part. We also need to subtract it here, and we also need to subtract it here. This is the way the book shows you to do it. If you do that, you're left with 2x. 9 minus 7 is 12. And negative 1 minus 7 is negative 8. Okay? So now what do you need to get rid of that's with the x? The 2. Okay. And you're left with negative 4, x, and 6. Now here's a question for you. Did we divide by a negative? Nope. So leave things the way they are. Once again, you're going to have this nice little 6 and down to negative 4. And open or close? Open. Open or close? Open. And it's everything in between. Now, this is what I found. Okay? What I found is that you have to, this is okay. Some of you, I think, would rather just split them up. 2x plus 7 is less than 19. And then think of this, 2x plus 7, well, let's see, the bigger side's closer, is greater than negative 1. Okay? And then you can solve them and work on the graph. Although remember, that usually gives you that closed-in one. Okay? Here's the last one. This is an OR. Okay, do you remember what usually happens in OR when you graph? Yeah, it shoots out to the opposite side. So let's see if it happens. We're going to add 1 to each side. Remember, put the equals in between. What are you left with? 3x. What are you left with? 0. Okay? Divide each side by 3. 0 divided by 3? Oh yeah, just 0. And we know on this one it's going to be less than 0. What will make this true? Any number less than 0. Let's come over here. This one's not too bad. Subtract 5. What you do to one side, you do to the other. And you've got 2x greater than or equal to 6. Okay? Divide each side by 2. We get x, we get 3. Do we need to flip that symbol? You're right, we do not. Okay, so let's try graphing this. Here's 0, open or closed, open and go to the left because it's less than. Here's 3, open or closed, very good, closed. And we're going to go to the right. And you notice it's got, here we'll label that, it's shooting out the opposite ways, okay? So we're going to practice this the next time you come to class and have a good rest of your day. Bye.